Okay, so test-driven development. And like I mentioned, we're not going to go through all of these slides, okay? So you may have noticed in the morning challenges where there are tests, we're using test unit. If you looked at those test files, we're using a part of the standard Ruby library called test unit. And we can use test unit to write automated unit tests. But we're not going to talk about that today because writing unit tests is also writing code. And we're covering a lot this week and I don't want to overload. And I think that I'll just avoid talking too much about test unit anyway and go straight to RSpec when we talk about automated testing for Ruby, because RSpec you're more likely to see in the field, okay? But do feel free to look at and understand the files that are in the morning challenges for testing, okay? And if you have questions about those, you can ask me. If you want to do some research on your own, feel free, and there is some information about it in this deck of slides if you want to look further and understand more, but we're not going to cover all of it today, okay? Today we're going to talk about what test-driven development is, why we do it, and then we're going to talk about how we can accomplish testing without using a formal testing framework and writing some tests that we run manually and then keeping track of the tests that we've written and run in a spreadsheet, okay? And this is an okay way to do things. It's not scalable. It's fine if you're working on a small project, something, you know, for class, or something that's a proof of concept, something that's really small and contained. This is a fine way to do things, and probably is preferable because you do have to spend extra time writing and maintaining tests. Writing automated testing is writing code, and you have to maintain that code, okay? Just like you have to maintain any other code. So it requires an investment of your time. And you might have to look stuff up to know how to do it. So it's going to even take more time, right? So the kind of testing that we talk about today is perfectly suitable for small projects. The problem is that once your project gets big, either in size or in life cycle, like it is out there for a while and you have to keep maintaining it, you don't want to have to manually test your code every time you make a change, because it'll just you won't be able to manage it. It'll be too much. And what will happen is you just won't test your code very well. And then what will happen is you'll release bugs. And then you'll feel bad because your code's buggy. So, and then if people are paying for your software, then they'll get angry. And they'll open tickets if you give them a way to, or they'll raise issues against your GitHub repo. And then your feelings might be hurt because you'll be like, oh, my code is crap. And it's not necessarily that your code is crap. It's just that you haven't done enough testing, okay? None of us, even if you've been doing it for 20 years, write perfect code. None of us, ever write perfect code. We all would release crappy code if we didn't test our code. Every single one of us. You have to test your code because you don't think about everything, because you're human and you make small mistakes, because you don't consider all of the corner cases and edge cases when you're writing something, and because customers or other people using your code are going to use it in ways you never imagined using it. And so it's really important not only that you test the code that you put out there, but as problems are found, you incorporate new tests that capture that particular circumstance so that you don't have that bug persist or reintroduce it at a later time when you make changes to your code, okay? But let's look at test-driven development. What is that? So there's testing and there's test-driven development. They're two different things, okay? Test-driven development encourages writing the test before you write the code. So you write the test before you write any code, and the test will purposely fail, and then you write the code until the test passes. So this is what test-driven development is. The benefits are that, number one, your code is going to be testable. Meaning, when I say testable, I mean it can be tested with automated tests. Okay? That's really important, because if you build a big monolith of code that you cannot test with automated tests, then that piece of code will fail. You know, it's going to fail you. It's going to be a disappointment. It's going to make you sad one day. because you're not going to be able to maintain it. So it makes sure that we write testable code. It makes sure that code changes don't break existing function. That's called regressions. When you have something that is working and then you change it and it stops working, that's called a regression. And programmers hate regressions. And managers and like product owners and things hate regressions even more. So regressions look really bad, and I can tell you every team I've ever worked on, we always had one of our like targets to measure our success as a developer on that team was how many regressions our team introduced and how good we were at reducing the number of regressions from release to release, because you don't want to put working code out and then break it. You know, that makes people really unhappy when you do that. So we want to prevent regression. So if you have automated tests, every time you make a change, you just run your automated tests. And that makes sure that things that were working before still work after you make this change, right? Because the tests all still run. Now, that means that you have to keep updating your tests, right? You can't just write an initial set of tests and be like, I'm done forever. My code is totally tested and testable. And then you make a bunch of changes to it and you don't write new tests. Or you find problems, you fix those problems, you better write a test for that problem, okay? Because you might break it again, and that's really embarrassing. When you break something once and then you fix it and then you break it again, and then people are like, what the hell are you doing? Don't you know what you're doing? And you're like, no, actually, I'm not a bad coder, I just didn't test it. I didn't write a test. Well, that doesn't become a very good excuse. You know, it used to be that we could say, well, that's the tester's job. That's not I'm a coder. I'm not a tester. But you can't do that. We're all responsible for the code that we put out there and that it works. It also has the benefit that it has you think through, what am I building before you build it. If you have to write tests that test, it does this, it does this, it does this, then you're thinking about, what does my solution have to do, right? You're writing tests to make sure it does those things. So it has you really think through your solution. And when you think through it this way, you'll think about things like, oh, no, this, you know, I really should have a function that does this. Or this really does require a separate class because this data structure is just too hard to test. And it has you think through those things earlier in the development cycle, which is good. So unit tests are a specific type of test that test the expectations in our code at the functional level. If we do this, we expect this result. Test our code too, and we use it to check our main code. Now, don't get ridiculous in the like testing and inception model where you have to test your test and you have to test your test that tests your test. Don't have to go down that road, okay? Test our code, but they're really simple code, okay? And sometimes, though, we write bad tests, and we have to change them because the tests fail in times when they shouldn't fail, all right? And that's just a bit of an evolution. So unit tests are used to test really small pieces of function, like methods, okay? Very isolated things. And so any method we've written so far could be unit tested, okay? If it's well written, it could be unit tested. All right, so you'll see reference to this red-green refactor cycle. And this is in reference to test-driven development. So the first case, and the first thing we do is we write a test that fails. So we run the test and it's all red. Everything fails. Then we make the code work, so all the tests pass. Then we eliminate redundancy. So as much as possible, we don't introduce redundancy, but our main focus in this step is just making the test pass. Not spending too much time on the beauty of the code. All right? And the reason that we do this is because some developers have a personality type that they would never get anything done on time if we just let them do things how they want to. So we put in a process like this that says we write the test, we're going to have all the tests turn green by the end of this sprint for this particular thing, right? And we make that a goal, and that just kind of helps some developers focus on, we need to actually complete this project. You know, we want it to be perfect, and we want it to be beautiful, and we want to have completely dry code with no repetition, and we want it to be all elegant and beautiful, but we have to get it done on time, or we're not going to have customers that pay for the product, and then we're not going to have jobs. So that's the reason for this cycle. Okay. All right, so we're not going to talk about this. I think we're going to stop there in the slides, and I'm going to shift gears a little bit, and we're going to create a spreadsheet. And I'll share this with everybody. Cafe tests. So, if you remember yesterday, we actually did write some tests. Do you remember that? We wrote some tests after we wrote our order class and our item class and our menu class, and we wrote some tests to make sure that those things all work. Okay, and that's an example of testing. And so we can, at the start, we can capture those. Now when we think about what is the information we want to capture about testing, so I think we want to capture the date when we're actually running the test. Okay, and then we want to capture, and maybe date doesn't go there. Okay, let's not start with date. Let's start with, we'll have a test name. We'll just give it a shorthand name that we can refer to in Trello if we want to. A test description that describes what are we testing. The files that are affected by this test or that are tested by this test. So we know where to go look if we have problems executing the test. And so we know if we make a change to that file, these are the tests that I should run again, right? Then we can have expected. So we'll have inputs. Not all tests will have inputs, but some will. Okay, we'll look at examples in a minute. Expected output, actual output. All right. So expected is what we expect our code to do when given that input, and actual is what it actually does when we test it. And for this, and we might just have a notes column. So as we go along, we might find that there's a reason to take some notes. Now we could use this sheet to capture these are the test descriptions. So here's where we're going to define a set of tests. And then when we run the test, we could just create additional sheets. Okay, and we can specify which test we ran, the date, the inputs, expected output, actual output, and anything we have to do as a result of that test, right? So first of all, let's have a look at what we did yesterday when we created some tests. So let's look at our code. And let's look at our order class. So in our order class, we had some tests down here. And you look at what are the methods, what did we test? So we tested we can create items and add them to an order. So this is in order.rb, but it also includes testing item.rb, doesn't it? Because if you look at that test, we create an item, right? Test name, we'll call this one add item. And maybe we might even be more specific and call it, and you don't have to follow along with me here, I'm going to share the sheet with you. Order, add item, just so it's clear what we're testing. Let me do this now. So you'll want to do something similar to this, all right, for your terminal app. Yes, Aiden.
So I've done this before. Is it, I mean, like, you're testing a website, for instance, if you break something old, just like user testing?
Yeah.
Is it then like test for it on launch?
Yes, absolutely. Absolutely. If you've got, so you'll have a list of tests that you're running, and say you're just like, you know, developing, testing your code, or somebody else is testing your code for you, somebody's reviewing it, and they find a problem, the first thing you should do is think, what tests can I write for this? Let me add it to my list of tests now. Okay? So the first thing you should do is write a test to capture that case. And if you find that particular thing isn't very testable, then that's a clue to you that you should create a Trello card to refactor this code to make it testable. Okay? So the test description I'm just going to take directly from what we wrote here. We can create items and add them to an order. So we already did this work, so we'll make use of it. Okay, I'm going to make this field slightly bigger, and I'm going to wrap it. You do what you do, okay? Whatever you like. I'll also bold the headings. So as inputs, if we look, we had this, and actually, no, this is fine. We had this, and then we had Alt-Enter will let you enter a new line in the same field if you don't know that. And we had this. So I'm just copying from our existing test because we created some tests yesterday. We'll create some new tests today. And our expected output in this case was that, now expected output isn't always clear, right? Because add item, what is add item's output? It's the order, right? So we could say that, and we could even put this whole string in there if we want to, but we could say that order.print order shows 2 items, right? That's what we expect. So order print order shows the 2 items with specified quantities, and so we could say specifically that's that we have, what was it, 2 lattes 2 latte and oops, and 3, is it 3? 1 scone. Right. I might make these a little bit bigger just for readability. I'll wrap this one. Okay, and for actual output, we could say matched expected, because that's what we saw, right? And so that's good. Actually, we don't need actual output in this field, in this sheet, so forgive me for just a minute. I'm just going to delete this one. This actually belongs on another slide, on another sheet, where we'll say test results, and then we might put, like, what was yesterday?
Do you have any context around test results?
Well, this is what we would do. So here's our test description. We have a name. We would say test results. We'll have a test name. Might put date first. Test name and expected actual. We'll put that stuff here. So we'll put 15 for, you might want to put the time, depending on what kind of schedule you're working on. You might want to say what time you tested it. Test name was order, add item. The expected output, and this is just for convenience, copying this bit, so when you're looking at test results, if you had to rerun this test, then you could, if it failed, say, you could run it again and you've got the expected output right there to refer back to. As expected, and then we don't have any notes to make here. Okay, so this would be what your test results page could look like. Now, yours doesn't have to look exactly like mine. I'm just giving you an idea of this is the kind of information you need to capture, the level of detail that you should be capturing. So we could add test descriptions for our other tests. So we had print order. We also tested that, right? And it was, we can print the order.
We made that to save that.
We do. So it gets tested anyway, right? But this really only involves order.rb. And the inputs are, we can give the same inputs because we have to have something to print, and we actually have the same output. Now, why do we capture these as two different tests? It actually brings up something that we might want to consider. We might want to be able to test add item by itself. We might want to devise a test that only tests add item and doesn't include print order in that test. Because what could happen is we could do a change that actually breaks add item, or that only breaks print order. And if the change only breaks print order, it could look like, we don't know then, was the problem with add item or was the problem with print order? We're not really sure, are we? So when I look at this, I can say, all right, using print order to test that add item works isn't really a good idea, because we could get into a case where print order is broken but add item's fine, and it's going to look like maybe we have to look at add item to fix something. So there's an opportunity to think about, is there a different way that we could test add item? So we add an item, and then we could just say, if we just say puts order, let's see what kind of output that we get. Oh, it's not order. What is it? Test order. So it just prints this. That's not super useful, is it? So what would make that more useful? So puts calls 2s. We could override a 2s because we chose not to do that with this. We did it with print order. Or we could we could override inspect and call print. Do you remember that? So print calls inspect on an object. That could be more appropriate for testing purposes, right? Because we tend to use inspect for testing and debugging purposes and not for the purposes of our application. Like we use 2s really commonly for applications. So if we added to our order class an implementation of inspect, and we can say, oh, not inspect, sorry. Yeah, inspect. So if we could say for testing, if we override inspect so that it, I think we have to puts for this, don't we? I'm trying to remember. Does anybody remember if we have to put to return? I'm just going to try something. So all I'm doing now is I want to see I'm going to comment the rest of this out for the moment. I'm going to run it. Okay, that did not do it, so you have to puts. That's what I thought. Okay, so we can puts when we call inspect. Now let's just test my understanding there to make sure. Nope, that didn't do it either. Was it not inspect? Somebody help me remember. We did this.
I'm pretty sure it was.
I thought it was inspect.
I can't remember his name.
We did it with when we were doing the dog thing, didn't we? Did I save it last time? Let me try that again.
Is it 2S?
It's 2S is what puts uses,
Yeah.
but
Right.
but print I think uses inspect. Okay, well we could just do this. I thought print, maybe it's P? Is it only P that uses inspect? Let's try that. I thought it was too. So let's test that theory though. Ah, apparently it's not. I thought it was too. But I guess print is like puts
So how,
without a new line.
how does that validate that it works?
It doesn't. So I was just doing a bit of a play there to see what the behavior of our inspect method has to be to get it to do what I want to do. So what will be useful though? What will be useful is for us to return order, return P order. Actually, return, if we say, that's not going to work. If we say, let's just try this. Okay, that works. Okay, so what this does is because our ordered class, remember, is actually storing its information in this hash. You remember that? It's storing the information in this hash. So this requires understanding how our class is defined and how it works. What I'm trying to do is test my add item method. When I call my add item method, I expect that it's going to add an element or update an element in this hash. Okay? So our order hash is a hash where the item is the key and the quantity is the value. We made ourselves a nice comment there to remind ourselves what we were doing here. Okay? So when I add an item, what I expect to happen is that this hash gets updated. Yes? And that's what I need to test. I need to test that this hash gets updated when I call add item. So what I did was I implemented an inspect method that just returns the hash. Okay? So when I print that, I can see the contents of the hash. Okay? So this is what it looks like. Can you see that? So it shows me our item, attributes, name, price, cost, and then the value in the hash is the quantity that I've specified. Yes? So when I run this test, I'm going to modify my add item test now. I'm going to say, this is our test that we can create items and add them to an order. I'm just going to put a blank line after this test because it's going to leave me sitting on the same line. right? And so that's the input, and my expected output now is this thing. Okay, does that make sense? So this is what I'm going to put in my spreadsheet. All right? And I'm going to copy that over here. Now, it's nice because my print order and add item testing are separate. Now, still my print order is depending on add item, isn't it? Because I don't have anything to print if I don't add some items to the order. And that's just something that we can't avoid. But what we can do is we can say if print order fails, okay, let's make sure that my add item test is working. And if my add item test is working, then what's wrong with print order is probably in print order and not an add item, right? It at least gives me that, which is going to save me some time figuring out what's wrong if something goes wrong. Okay? So, print order, we can print the order. Let's just capture these other ones quickly that we've created. Oh, what happened there? I don't know where this came from. Okay. I'm going to uncomment these again. Okay, we can print the order. We also had testing with an empty order. We'll get to that. Okay, we can print the order. We can calculate total profit. So let's capture that one. We can calculate the total profit. So this is going to be order dot total profit. Now, this is another case, right? We talked about this yesterday, where we're actually testing multiple things, aren't we? Because what does total profit do? Well, actually, it's different now, because now we moved profit to items. We don't have total price and total cost. So testing total profit is fine, but we also need to add a test for total price. So that's okay. Okay, so testing for total profit also depends on add item. So we're assuming that we've added these, so let's copy that in because those are inputs to it. And this also is testing order.rb and now item.rb, isn't it? Because our updated total profit method actually calls on item to get its profit. Do you remember that? We made that change yesterday. So as we build out this spreadsheet, we should be thinking about other things we need to test independently. Like right now, we can see, all right, we probably need some testing since we added a method to item called profit. We probably need some testing just of that method to make sure that that always returns what we expect it to. So we'll make a note here to add a test. And then you could be creating cards for this as well in your Trello board. You know, so we can go to our Trello board and we can say add tests, and then the ones that we've thought of are item, total profit. We might think of others. For the moment, we'll make this small, but now we've got it in our to-do list so we don't forget. Okay, so in this case we expect our total profit to be 13, I think. But this is where, you know, we would actually do the calculation and make sure that what we think is the total profit is right. So we could do some maths here, which we could do in IRB. So we have the price is 4, and we have 2 lattes, so 4 times 2 is 8. And then we need to subtract is 4. Okay, so we have 4. Just write that down so we don't forget. And then for scones, we have the price is 5. We have 1 of those. minus,
3 is 2.
so that's only 6. What did we come up with when we ran it? Save. Oh yeah, it was 6. Okay, that's good.
You're thinking of the total cost.
I was thinking of the total cost, yep. Okay, so 6 is what we expected, and we just checked that that was true. So that's good. So we expect here the output to be 6. Okay, so we can add these to our test results. We can kind of copy these fields, paste them in here, copy the date, paste them in here, copy our inputs, and paste them in here, and oops, that wasn't expected output, that's what we wanted. Paste those in here, and we'd say as expected, as expected. Now, let's just introduce a problem. What if we said, what if we introduced a problem like this? We just left out that little plus. Somebody went in and the cursor was there and they did a backspace and didn't realize, and then they saved it. And then we run the test again. And we get,
You're not getting anything.
yeah, no, we are.
Alright.
We are. We actually just got the same results. Did I not save? Yeah. There's something I didn't save. No, I don't expect that to work. So if we make order item equal, oh, I know why. Okay, so actually it still passes. We can't even tell there's a problem. We run it again, and we can't tell there's a problem. And then a user uses our app, and they enter this case. I'm just going to create another one.
I think it's because you start with 0.
Yeah, that's right. Yeah, that's right. That's right. Yeah, that's totally right. So our user, though, uses the app, and then they order latte twice. Yeah? They order latte twice.
4 and 2.
Mm.
You want to change
So,
the amounts to 4 and 2.
no, I'm going to leave it like this.
Right.
So, oh, no, you're right. Sorry. No, you're right. The price and the cost. That's correct. Okay. So now, what do we expect when I run this case? So if I order a latte, the first 2 lattes, and then I order 1 more latte, what do I expect to have in my order hash? 3 lattes.
Yeah.
Yep?
You're not getting any.
I'm not going to. That's right. So in this case, let's create a new test for this. Order, add item, and you might want to sort these later. We can add the same item twice. And then our inputs here are
Where does it get the other column?
hmm?
Where does it get the other bracket from you?
I don't know. I'm going to paste this in and change it though. It feels easier. That's what I expect, right? And then let's see what happens though when I run it. Oh wait, I have to change something else. So that's a problem with my test. What's the problem?
Oh, because you're running the first test and running this next test.
Yeah, and I'm reusing the same variable.
You need to comment out the first test.
I could comment it out, or I could use a different variable here. Either way. So this is where testing manually can get a little bit messy, but that's all right. Or I can reinstantiate test order.
It's just getting the last result, isn't it?
So what did it do?
Oh, no, it did it.
Yeah, but is that how I expect it to be?
You printed each result, that you ordered 2 lattes and you ordered 1 latte.
Look at my hash.
It didn't add the latte to the already existing key. It just created a new key latte.
It did. It did. And that's not what we want, is it? So if I go back here, I don't think I put in my expected result. My expected result is that I get something like, it might not look exactly like this, right? Because the object ID is going to be different, but that's okay. But it's going to look something like this. That's what I expect, right? Something like that. Where I've got one item in my hash, it's a latte, and there are 3 of them. That's what I expect. Does that make sense?
You just put that in the cell where the 6 was. Just,
Did I?
yeah.
Yeah, all right.
Or a bracket or something.
So this is what I expect, but when I ran my test, and I really should give this one a different name. And what I got back looked like this.
It's just you didn't have a plus.
Yeah, so this would be, so I would make a note, something like not updating existing entry in order hash when the same item is required. I'd make a note. And then I would go look at the code. I'd probably create a Trello card. Create a Trello card and to do. It says maybe bug or something like that. Order, add, item, not unique, test, failed. So I might create a label for bugs. Make it red. And I might want to move that up in the priority list because it's probably going to impact everything else that I'm doing, right? And so maybe I'm the person who fixes that bug, or maybe I'm in the middle of doing something else and I just noticed this problem. I documented it. I created a Trello card. Maybe, I look for the person who introduced that bug, the last person who had their hand on that class. So I know which file I know it's related to one of those 2 files. I go look at the git commit history and see who updated that file last if it wasn't me. If it was me, I'd probably try to just fix it. If it wasn't me, I'd go look for the person that did the last commit on my team and say, hey, there's a bug. I think it's in the change that you just made, or the last change that you made. Can you have a look? and maybe put their name on the Trello card, and then they would go fix the bug, right? And then when you do your retrospective at the end of the sprint, there's, you know, you can talk about, okay, why did this get missed in the code review process? You know, what can we do to prevent this kind of bug from coming in again? One of the things we did is we'll add a test for it. Maybe we came across this before. We added a test for it. So that's one thing we can do to prevent it like being released out into the world. Yeah, Aiden?
If this was actually again a working situation, would they usually have their own branches and they test their own branches before committing to master?
They would, but let's say we tested it and we didn't have this test to start with. Let's say when we started we didn't have this test with a unique case, and we only had the other test, which didn't show a problem. The other test looked fine, right? So somehow, in someone testing this, or maybe a user found it, hopefully not, hopefully we found it in our testing, we came across it. And so as I came across it, I added a test to the list of tests, and I created the card for the bug fix. And then, so if I'm the person who introduced that problem, I'm like, oop, my bad. I'll put myself on that one. Put it in progress. Go fix my bug. Run the test again. See that it's this one. Did I save it? Maybe we have a problem in our code. An actual problem outside of that one.
Is this like a needed test?
I think because you created latte twice.
Yeah, so what I expect it to do is to find that item already. Oh yeah, because I created two distinct objects. So that's a problem too, and that's actually a problem with our implementation. That's a problem with our implementation. So either in our and we haven't implemented our cafe yet, but right now I've made an assumption that when our cafe adds a new menu item, we're just going to call latte new. If we want to add a new latte, and that's going to create a new object. And if that's the way we do our implementation, this isn't going to work. Right?
But it is correct in that you did order 2 lattes.
Yeah,
and you did order 1 latte.
but it's not our expected behavior. If it is correct, but we don't want to print an order saying 2 lattes, then 1 latte, then, you know. Yeah.
You're using your menu to return a reference to the object that won't happen anymore.
Say again?
You're using your menu to hold the references to that object. It shouldn't happen anymore. So using latte menu, you should be grabbing that item from the menu.
Will it though? Let's look at our implementation. So, yeah, so if we do get item, you mean?
Yes, if you use add item, pretty much populate
Yes.
get item.
Yes. Yes. Okay. So now what do we need to do in order to reflect this in our test? Yeah, so we had made the change sort of late in the game yesterday. We said if we have a menu class which stores our items, so it's got one of each of our items with their price and their cost. It's just like our menu. And from our cafe class, we'll be called to get an instance of a named item. So instead of creating a new one each time, we only create new ones from our cafe at the very start when we initialize the menu, and we call add item. So we call add item, call to initialize menu with items, item instances. Okay, so if we used get item in our menu class, which is what we're going to plan to do from our cafe, instead of explicitly calling item.new in our test.
You could do work around it just by initializing
initializing a latte object. We could. So if we said latte equals latte new, which will require that we bring in our menu class. So that we'd have to do either way, wouldn't we?
No, what if you just testing the order? You just need to create the item.
Say again? If I'm testing the order and I'm going to use, oh yeah, never mind. You're right. You're right. No, you're right. You're right. But latte's defined there. That's why.
No, that's where you're saving an instance of it.
But I defined the latte subclass.
Oh,
Yeah, in there. So if I pulled that out and put it in something called menu items or something on its own, but for the moment we'd have to require menu. So and this is just for testing purposes. Then, instead of doing this, I could refer to this thing that I saved, this instance I've saved, and it won't create a new object.
I want to copy that
Hmm?
and where you've got latte new. Oh, is that pretty fine, is it?
Yeah, I'm just defining it in a variable, so we just create a single instance of a latte.
Yeah, sorry.
Yeah, that's all right. So, oops. Okay, so what we had to do here was, the problem was that our order class uses an instance as a key, an object instance. And that object instance is going to have a specific ID. We can see that when we print the class. Can you see that? This item object number is different from this item object number. So this one is 3E8, it ends in 3E8. This one ends in 398. They're two different instances. And that's why we ended up with two different elements in our hash. But this was a case where a test was bad, because our actual implementation that uses order, the idea is that it will use our menu to create items. And the menu is going to keep up with a single instance for each menu item. So there'll only ever be one latte item. There'll only ever be one scone and one tea instance in the menu. So we won't ever have two different object IDs when we add lattes multiple times. Okay? So, so this won't be a problem. Let's just verify that that's true. If I change this, so now I'm using the same object. See that? The same latte object both times that I add an object. And this mimics what we'll be doing from our cafe app. Okay? Then what I expect is to get the result that I wanted. And I do. See that? I have one item in my hash now when I make that change. So now I'm going to go back to my testing sheet, and I'm going to say I'm going to repeat this one. So let's say that this one was on 15.4 and then on 16.4. I change the input. No, that's my expected output still. And as expected, and I'm going to say depends on application using menu to generate the order items. So we have only single item instances. Okay, so I make that note so that I know that I've introduced this sort of dependent behavior, you know? So if at any point I decide to change my implementation, I at least have a record somewhere, okay, of this dependency. So because what would happen is, say in the future, I change my implementation and I don't use the menu class to generate this instance, and then suddenly this test fails. Then I would do is I would go back and look for the last time it passed. I would look for the times that it passed, and I might see this note, right, that says, oh, this depends on this. Maybe something changed there. And then I also actually need to change this, because also now we're depending on menu RB for this test to behave the way that it does. So you can see that it can be quite a tedious thing to keep track of this way.
Yeah.
And why it would be okay for small projects, but if you had a really big project that's scaled, in size or over time or number of users, forget about it. There's no way you're keeping track of this. You would get frustrated. You'd be like, yeah, screw that. I'm not updating the spreadsheet. I don't got time for that. So this is, you can even see with this with this small project that it would quickly become unmanageable. And this is why we write automated tests. Okay. So let's just look at one case of adding a test for something we haven't implemented yet. Okay? So far what we've done is yesterday we did some development, and after we developed the thing, we said, okay, let's test and make sure this works. So let's look at the different approach, the TDD approach of there's something we haven't written yet. There's plenty we haven't written yet in Cafe. And before we write it, let's write a test that will test it. Okay, so in our Cafe, we initialize the order and menu, and then we're going to, we will print the menu, and then I'm just going to write down the steps that our Cafe needs to do. So we'll print the menu, then we'll ask the user for their order, then we'll get the user's order, and if not quit, we'll ask for quantity, then we'll add the order, add the item to the order, and we'll do that in a loop, right? Repeat until quit. And then after that, we'll print the order. That's basically what we want our Cafe app to do, yeah? Okay. And we might print the profit for the Cafe owner. Okay. So, yeah, it's all right. So we're going to print the menu. So maybe let's think about, where's our loop here? It's basically this block here, isn't it? I mean, we could just decide we're going to print the menu once, but we might print the menu every time. So maybe we don't print the menu every time. Maybe we just do this bit in the loop. So we'll have loop starts here, and loop ends here. So we're going to have a loop there, right? So we're going to have a print the menu. That could be a method, couldn't it? Print the menu could be a method. But maybe we don't need one, because we put a 2s in here, didn't we? That's pretty straightforward. That's pretty straightforward, printing the menu. We just call 2s. Now, and we've got a test for that too already, so that's not super interesting. Let's go back to Cafe. Let's find something that's more interesting. So here we'll just say menu 2s. All right, so let's think about our loop. In the loop, what kind of loop do we want? We'll have a while loop or something. We'll ask the user for their order, and we'll get their order? Is there an opportunity for us to have a method there? Maybe where we get an input from the user and
Well, it's just you ask the user for that order, you don't get the quantity before it.
yeah, so we ask them for their order, and this is their opportunity to say, I'm done, right? So we're going to ask them for their order, they're going to type something in. It's either going to be an item on the menu, quit, or something that's not on the menu and not quit, in which case we're going to tell them it's invalid, right? So can we capture that in a method? Can we have a method, get an item from the user for the order? Maybe get item from user. Now let's think about what this method's going to do. So it will do we want to pass input to it? Do we want to prompt the user for what they want in here? So we could ask the user for their order. Then we could check the input. If quit, return. And maybe we have to return something specific, because let's think about if an item has quantity, maybe we just want to leave it to getting the item and we return the item from this. That's one way we could do it. We can get the item and return the item from this method. Or we could return.
Do you want to just do it in one?
We could. I'm trying to make it modular so it's testable, because if we just do it in one loop, then we can't really test it on its own. It's not very testable. And that loop actually does quite a lot. And if we break any part of that loop, then the whole thing breaks, and we only have one test to capture that case, right? So what we're trying to do is trying to break it up a bit. So trying to work out, is there a place that we can break this up so we can test a specific thing? So how are we going to add the item to the order? We're going to call order add item, aren't we? Which is pretty straightforward. There's not much to that. We've already tested that. We could put this whole bit in a method, this whole loop in a method, and that way we could at least just test calling the method, and we can control the inputs and so forth, or the setup that way. So that's one thing we could do.
You could just test different functions of it, couldn't you? You know.
So what do you mean?
Well, you could. What happens? You know, if you when you test doing an order, can you test quitting?
Maybe we ask the user, we add the item, we get to the point of adding to the item, and then we ask the user if quit, we return nil, and if item, add the item, or we could just return quit, and then if invalid, return invalid. So what this method does is get item from user, get item from user, add to order. So then our loop would look like, we would call get item from user add to order, and it's going to return a value. And then our loop would say, while result does not equal quit, right? Get item add to order, and then we'd say if result equals invalid. Actually, we don't have to do anything there. We just keep looping. Okay, so if we decide to do this, so we have a method called get item and add to order, and its job is to ask the user for an item, and if we get quit, we return quit. It's actually nicer if we pass in the user input, because it makes it more testable. Why? Because then we can run a test against this method with the input and see that we have the expected results. Okay, so instead of prompting the user here, we get the input outside of this method. So we're going to ask user for input, and we're going to pass the input to this method. Now what this allows us to do is to write a test for this method. We have an input, and we're going to have an expected output, where the expected output is one of these three things. Okay? If the input we got from the user was quit, we expect this method to return quit. If the input we get from the user is not one of the things we know about, we expect the output to be invalid. And if the input is one of our menu items, then we expect the output to be the item, add the item, and return the item. So we expect that we're going to add the item to the order and return that item. So now we have something we can test. All right? So it took me a little bit to get there, and the things that I think about are, what can I pull apart that I could test individually that is a useful piece of function for this application, that I can test and retest just by giving it different inputs and checking the output that it gives back to me. And this is a really clear way to do that, isn't it? I have a clear input, and then I'm going to have a clear output to test. Okay? So this is one of the things that test-driven development can do, because if I just started writing it, I probably wouldn't have come up with this. But this is going to make it really easy to test this going forward. And if I make changes to it, it's going to be much easier to test that those changes aren't breaking something. And if they do break something, for me to be able to tell where I need to look for the thing that's broken. Okay? So let's write a test. So my test is going to just call this method with input. So I'm going to test add item, and what do I call it? It's a really long method name. That's okay. And add to order. With quit. So I'll test it with quit. And then I'm going to test it with cheese, which should be invalid, right? And then I'm going to test it with latte. Okay? So with quit, I expect it to return quit. And with cheese, I expect it to return invalid. And with latte, I expect it to return the item itself, which will be a latte item. So that's going to be, I'm just going to put a latte item. Okay? So now I'm going to call the method, add item and add to order, quit. And now I'm going to run this. Let's just make sure I don't have typos elsewhere or anything. It should be all right. Okay. I'm going to comment this one out for a moment. So, and it says no method error. Did I call it something different than what I typed? Get item and add to order. Right. You have to call the method by the right name. Okay, let's try that again. Okay, I might want to comment out my other tests, which is another thing that is kind of annoying when you're testing this way. When you're done testing this, we'll comment that out. And also in menu, we've got some tests that are running. Let's try that again. And it didn't print out anything. Maybe I'll add something in just so we know it was called. We actually don't expect it. We have to do a puts in front, don't we? And it print out nothing, right? So I might want to put something in my empty method here that's just like a puts in something like that, just to make sure I'm calling my method. Okay, I'm calling my method. It's not returning quit though, and that's what I expect. So now what we do is we are going to, now that we know we're executing our method, we can comment that out. Now I just want to pass this test. So how can I just pass this test? Just this one test. That if I pass and quit, it returns quit.
Maybe if input equals quit.
Return quit. Exactly. Yay, it passes. Done. No, not done. Okay, let's check the other ones now. Okay, so now and what I expect here is it should print invalid, right? Okay, let's run it. After I save it. No, it didn't print anything. That doesn't surprise us though, does it? All right, how do I make it pass for this test?
Put an else if statement.
What if you just change that and if you put if input does not equal quit, return.
I could. I could. But I'm still going to have an else, won't I? Just to return quit. So I could just here, I could really simply just say else. Yeah, but just to, so TDD, you just want to make the test pass. As you add them, you just want the test to pass. And I feel good about this one. This is going to work. Yes! We did it! Not done though. So now we add this third test. Okay. Now let's try to run it. Oh, bummer. That's not invalid. Okay, but we know why that's happening, right? Okay, so now we have to fix it though. So the test is broken, we have to fix it.
Put an else if in between the if and the
Could
else.
you just put
You
two?
could.
Could you just put when input equals quit and or this?
Well, we're going to have to deal with the case.
Else if means not E.
Oh, yeah.
Take the E.
That's all right. Okay, so if we did this, Yeah?
Need it to return.
Now we could just make it pass by just saying
Return
something like menu.get item latte, which is how we get a latte, by the way. This is going to pass, I think, but it isn't quite right, though. Oh, no, it doesn't pass. No. Menu. What is it? Menu. So we're going to have to pass menu in here to get it to work. So that just failed because undefined local variable or method menu. Okay? And that's because my menu is defined as a local variable. See it here? Local variable. And unless I want to make that variable global, and I don't, then I need to pass it where I need it. And so in order for me to access menu from inside of here to get the item from the name, I'm going to have to pass menu in. So that's already helping me. I need to make a change to this method in order to make it work. So now we're going to change each one of these to pass in menu. Okay, let's see if that fixed that. Yes! Winner! Okay, but the method still doesn't do what I want it to do because it isn't actually adding it to the order, is it? I'm not testing for that. I'm just testing that it returns what I expect it to. So I probably also need to add a test here that after this happens, our order's updated. How do we know if our order's updated? So we've got our order here. So what do we expect after this method is called?
For latte to be added
To the order. Yeah.
Check whether or not it's added to the order. You can just do that and print out the order.
We could print the order, or we could do our order dot inspect or p order. We could do our p order, right, to print the order. Okay, and then what we expect is expect order to contain a latte. But it doesn't. It's empty. So we have more work to do, right? All right, so we're going to stop there because it's noon. And I might leave it as, we can do it together this afternoon. If you want to try before we reconvene to get this to work, I'll push it up to the repo. And then we can, you know, if you come up with a solution to this, then we can talk about that solution. Not going forging ahead with everything, but just getting this method to behave the way we want it to, okay? So that this test pass. Okay?